right, so today we are graphing the reciprocal function. So we're going to start with cosecant. Make sure you're where it says cosecant on your notes, since the three parts kind of look the same. The other thing is this board makes my handwriting look even worse than it normally does, because before you even touch the board, it starts writing, and so I have to really pick up my pen before I put it back down, and that's going to take some getting used to too. So I may rewrite some things, and I may just say that's what that is, and I'm not rewriting it. So we'll just do the best we can today. Okay. Until I practice. It'll come better with practice, I know, but it's just different. F of x equals, so we're on cosecant of x. Okay. What is cosecant the reciprocal of? Sine. Okay, so cosecant of x equals 1 over sine of x. So in order for us to create the cosecant graph, and you're not going to do this every time you graph, but this is for us to create all these on this page, and then I'll show you what we're going to do when we actually graph them. We're going to use the sine function. So what I intended to do, which I can't, here's the other thing. I can't really make dotted lines, haven't figured out how to, because when you make dotted lines, you don't pick your pencil up very much, so it just looks like a straight line. But what I'm about to draw on here, what I want you to do, the idea of this is it's kind of going to be in the background. So with your pencil, you want to do it lightly and probably dotted so it doesn't look like the main part of your graph. You with me on that? I can use lighter colors, but that's what I'm going for here. So we are going to sketch in the sine. So I have for sine, I would start at 0, go to 2 pi, and then I also have a 0 at pi. At pi halves, I would be up at 1. At 3 pi halves, I'd be down at -1. Okay? So when I sketch this in, which the best I'm going to be able to do right now is just draw it, but it would look like that. But probably better, but again, it'll get better. Okay, so yours should be kind of lightly in the background on yours. Then we're going to use this to help us get the pieces we need for cosecant. So when sine is 0, cosecant is the reciprocal. What's the reciprocal of 0? Undefined. And how do we show undefined on these graphs? Asymptote. Good. So where sine is 0, I'm going to have an asymptote for cosecant. So you're going to have, and again, these, usually if I'm graphing, I make them dotted lines. Mine are going to be solid, but in a different color. So I have an asymptote here. I can put an asymptote at every 0 that I have for sine. Okay, so see, having that sine function in the background just helps me get them in the right place. Okay? When I'm plotting points, because just so when I try and make a point, that's what happens every single time. And then I have to make another point to make it go away. So until I can figure out how the heck to actually plot a point on this, clearly these boards were not vetted by math teachers, because I'm about to lose my mind already, and this is only period number 2 that I've been doing this. I'm going to make little ugly X's probably so you can actually see my points. But you can continue to make points like normal. It's not like this is a new thing. Okay? So at pi halves, sine is 1. What is the reciprocal of 1? 1. So I'm still at 1. When at 3 pi halves, sine is -1. What's the reciprocal of -1? -1. Okay. So that may or may not be enough for us to understand what's going on here. Probably not. So for this right now, we're going to plot a couple of more, but then once we understand what's going on, we won't have to plot these extra ones every time. All right, so let's look at pi fourths. What is the sine of pi fourths? Square root of 2 over 2. And then what's the reciprocal of that? Square root of 2. Okay, so that's about 1.4. That's going to be good enough for us to get on this graph, okay? So at pi fourths, the cosecant of pi fourths is square root of 2, which is about 1.4. So we'll go to 1.4, and we'll put another point. Okay? So that's at pi fourths. Here's 3 pi fourths. The sine of 3 pi fourths is what? Square root of 2 over 2. Use the graph. Think about that. Even if you're not sure, like if you're not sure what, so we think about it, what we've been doing with these is, okay, it's in the second quadrant and sine is positive, okay, and that's all correct. But when I'm here, I can see, I know it's the square root of 2 over 2. No, look, it has the same y value as this, so clearly they're both positive. Does that make sense? So you can use these graphs to kind of help you with those values in the positive and negative also if you understand what's happening with the graph. So that means if sine is square root of 2 over 2, cosecant is square root of 2, so I get another point right there. At 5 pi fourths, what's the sine of 5 pi fourths? Negative square root of 2 over 2, right? Which means the cosecant is square root of 2, negative square root of 2, sorry. So here I'm going to go negative 1.4-ish and end up right there. So 7 pi fourths, what do you think the cosecant of 7 pi fourths is? Negative square root of 2, so I have another point right about there. Okay. So those extra 4 that we just did, we did them this one time so we can understand what's happening with the graph. But we know with the asymptotes here, clearly this is going to come down and come back up, and then it's just going to hug the asymptote. So it looks very much like a parabola. It's not a parabola because we have the asymptotes, but it has that shape. Okay. Oof. There we go. Okay, we're good with that? So this is one cycle of cosecant. If you look at it and think about what's happening, it's almost like we took the sine function and turned it inside out. That's kind of what's happening there, all right? So then we can, so what's the period for a cosecant parent function? 2 pi, just like it was for sine, right? Now we can use this and we can repeat, so let's put in our other asymptotes. That means I should have one at negative pi, and I should have one at negative 2 pi. Okay. And then we know we're not going to draw the rest of sine behind it because, like I said, we're not actually going to draw it on the other graphs. But, you know, sine comes down like this and then back up. So these just alternate. I have a point here and a point here. And because we know what's happening, we don't need the other ones because we just want an idea of where things are and what the shape is. It doesn't have to be perfect. The whole idea of understanding these graphs is really just to understand like where it's positive, where it's negative, where it moves to, things like that. So this is good enough to get the rest of this in. And it's actually a little easier to draw when you're trying to hit those other 2 points anyway. But that's basically what your cosecant parent function looks like. And then what you're going to draw, because remember, we're going to draw little parent functions that we can follow every time. We are going to draw the parent function for sine. We're not going to draw a parent function for cosecant. We're going to draw this and use it kind of like we used it here, but a little bit easier and differently. But on those 3 parent functions that you've been drawing to graph, same 3 you're going to keep drawing. Okay, we're not going to draw other ones. We're just going to create it every time. Okay, we're good? And then I'll explain that more once we get there. Okay, so let's talk about the domain. I'll scroll just a little bit so you can still see it here. Is the domain all real numbers? No. What messes up it being all real numbers? The asymptotes. Okay, so that means I have the set of all x's such that, now I'm saying what x can't be, so then I'll say x cannot equal, all right, how often do they happen? Every pi, so this is going to be n times pi. See, my pi looks weird, but that's n times pi. N times pi, do I need to add anything? When n is 0, I'm at 0, so I'm good, right? And then I need to say where n is an element of the integers. And even though I've said you don't have to recreate that, you still don't have to, but by now you probably could do it pretty well, you know, at least get close to what it should look like. All right, is the range all real numbers? No. Where do we start? Negative infinity, right? We never include that. Then we go to what? Start at negative infinity and go to negative 1. Do I include negative 1? Yes. Ignore those extra marks. Those are made by my knuckles because I have to learn how to write on this. And then I start back over where? 1 and go to positive infinity because I'm going from bottom to top. You're fine. It's okay. We good on that? What about my zeros? None, right? I don't have any zeros. Y-intercept? None, because I have an asymptote there, right? Asymptotes definitely have those. Those are directly tied to the domain, because that was the only thing affecting my domain. So this is not a set of x's, because these are equations of lines. X equals n times pi, where n is an element of the integers. Do I have an amplitude? Kind of. I'll accept that answer. We kind of think about an amplitude, but the actual definition of an amplitude is half the distance between the max and the min points. So do I officially have one? No, because I don't have a max or min, so there's none. So I still have an a value that's important to me, and we think of it like amplitude, but it just doesn't have the fancy name anymore. All right, and what's the period for the parent function? 2 pi. Okay, good. All right, everybody good so far? All right. Yeesh. All right, so my transformations. F of x is equal to a times the cosecant of b times x minus c plus d. So when we talk about a, the absolute value of a, just like it's been since Algebra 1, it's still your vertical stretch or compression. The period is still just one cycle, but to find that from here, I would take 2 pi and divide it by the absolute value of b. The frequency is still the absolute value of b. And to find it, we would still do 2 pi divided by the period. Horizontal shift, which is your phase shift, is still c. Vertical shift is still d. Midline is still y equals d. So obviously some things have changed, but really all your transformations are the same. It's just that we don't call a amplitude. All right. What questions you got? All right. Then let's look at secant. Secant is going to be f of x is equal to the secant of x. What is secant the reciprocal of? Cosine. Remember, there's only one co in each pair there. So just like we did for sine, we're going to sketch lightly a little cosine parent function in the background. So that means I would start up here at 1, and I would end at 1. At pi, I'm at -1, and then I have zeros here. So you sketch it in lightly. Probably dotted line would be the best. I'm just going to use a really light blue. It's the best I can do right now. So beginning, we're at 1, right? What's the reciprocal of 1? 1, so I'm still right here. At the end, I'm at 1, reciprocal of 1 is still 1. At pi, I'm at -1. What's the reciprocal of -1? -1. So all those points stay the same, right? But then where cosine is 0, what will secant be? Undefined. So everywhere cosine is 0, we are going to have a vertical asymptote. Then since we just did cosecant and we're doing secant, do you see some similarities? Yes, and just like cosine is just sine that's shifted over, secant is just cosecant that's shifted over. So yes, we could go ahead and plot those other points, but I don't think they're necessary because the same kind of thing's happening, right? We know that this looks like this. This is going to look like this. Oh, actually, let me redo that because I just want to do one cycle first. I'm just going to go to here. I'll come back and fix that. And then here. So that is one cycle of secant before it starts to repeat. Okay. Knowing that much, can we finish off this graph? Okay. All right, so go ahead and complete your pattern here. So I'd have an asymptote at negative pi halves and negative 3 pi halves. And then I would be down here and up here. And then I will kind of let this finish off over there. So just like cosecant was basically sine turns inside out, secant is like cosine turned inside out. Then for when we graph the parent function for secant, we will draw a little cosine parent function. What questions you got? All right, so let's look at the rest of this then. Domain, not all real numbers, right? So we say it's the set of all x's such that x cannot equal. How often do the asymptotes happen? Every pi. We start at pi halves, and that's important, but they happen every pi units. So that's why we have this n times pi. This is our, n is like your slope, right, your rate of change. And I'm sorry my pi looks weird, just deal with it for right now. N times pi, but since if I put in 0 for n, I end up at 0, and I don't have 1 there. This is why I have to add that pi halves, so it shifts over a little bit, where n is an element of the integers. We're good? Is the range going to be the same as it was for cosecant? Yes, it is. So I start from negative infinity, and I go to negative 1. Then I start back over at 1, and I go to infinity. What about zeros? None. Do I have a y-intercept? Yes. It's at 0, 1. Okay. Remember, asymptotes and domain directly tied to each other. So my asymptotes, x equals n times pi plus pi halves, where n is an element of the integers. Amplitude? None, period, 2 pi. Any questions about any of that? All right, transformations. F of x equals a times the secant of b times x minus c plus d. A, absolute value of a is really what we want. It's your vertical, stretch, or compression. To find the period, we take 2 pi and divide it by the absolute value of b. Frequency is the absolute value of b, which we get from our equation. To find it if we need to, it is 2 pi divided by the period. How many times have we written that stuff down? Like a bazillion, right? And there's still some people that have no clue how to do that, and I don't know where you've been, and I don't know how to help you. Phase shift is still c. Vertical shift is still d. Midline, y equals d. Okay. We good? All right. Cotangent. F of x is equal to cotangent of x. Cotangent is the reciprocal of what? Tangent. So just like we did for sine and cosine, I'm going to sketch a little tangent parent function in the background here. So that parent function starts at 0, ends at pi. At pi halves, I have an asymptote. And again, do that lightly because we're going to have other asymptotes, and I don't want you to get confused with what's the graph and what's not. Halfway between these two, we went up 1, and halfway between these two, we went down 1. So this is basically what the parent function looked like, the little sketch that we did to graph it. Okay. So everywhere where tangent is 0, what is the value of cotangent? Tangent has a value of 0. Cotangent's value would be the reciprocal, which is undefined. Okay, so since this is my tangent parent function that I have lightly sketched here, I'm going to, everywhere there's a 0, I get to put in an asymptote. Because the reciprocal of 0 is undefined. Now, where tangent has an asymptote, tangent is undefined. The reciprocal of undefined isn't anything. But the reason we get undefined is because we put 1 over 0. And the reciprocal of that would give me what? What's the reciprocal of 1 over 0? 0 over 1, which is 0. So where tangent has an asymptote, cotangent has a 0. Then where tangent is 1, what's the reciprocal of 1? 1. And then we have a -1. The reciprocal of -1 is -1. My favorite answer to that I get all the time is 1/2. I have no idea where that comes from, but it makes me laugh. All right, so now that I have those three, I think we can sketch in what this looks like. So we didn't really turn tangent inside out like we did for sine and cosine, but what did happen is cotangent is just tangent reciprocal and shifted, it's been reflected and then shifted over. So it's going to have the same basic look. That's why having the parent function so you know, put down what we already know so that we get it turned the right way and all that good kind of stuff, because we will have reflections and other things in there. Okay, we good with that? Can you complete this graph? All right, go ahead and repeat your stuff and get it all completed in there. I will do the same. And then the parent function we're going to draw off to the side will be the little parent function for tangent, just like we did. So we're consistent. Consistency is the key here. Whether it's their values or their graphs, I would suggest that you always tie the reciprocal stuff to what you know about the originals, just because it makes everything a little bit easier. Okay. Any questions at this point? We're good? Okay. All right, so domain. Is our domain all real numbers? No. Okay, so it is the set of all. It is the set of all x's such that x cannot equal. All right, how often do the asymptotes happen? Every pi. That's what makes this n times pi. Do I need to add anything to that? No, because we start at 0. I just need to say where n is an element of the integers. Is the range the same as it was for secant and cosecant? No, because we don't have that gap in the middle. I start at -infinity, and I go all the way to infinity because it's all real numbers. All right, Zeros, do I have any? Yes, I have a lot of them, right? An infinite amount of them, so I'm going to have a set here. It's a set of all x's such that x does equal, see, I was eliminating something here. Here I'm saying what they are. How often do my zeros happen? Every pi, because like this is pi halves, then pi halves gets me here, so it's still every pi. So I still have n times pi. But the reason we want to say pi halves is because that's where we see the first one, right? So that's why we have to add it so we can shift this over a little bit. Plus pi halves, where n is an element of the integers. What about y-intercept? There's none. Good. Asymptotes, I definitely have them, right? These are connected, so my asymptotes, x does equal n times pi. Okay, it should match whatever my domain says here, where n is an element of the integers. Do I have an amplitude? What do you think? Amplitude is half the distance between the max and the min points. Can I find the max and min? No, I can't because they go to infinity. Yeah, does that make sense? Okay. Now, we still have an a value, but it's not the amplitude. It doesn't have a fancy name. What's the period here? Pi, just like it was for tangent, right? And that's the biggest thing, is that you have to remember for tangent and cotangent, the parent function period is pi. Okay, we all good with that? All right. Our transformations. F of x is equal to a times the cotangent of b times x minus c plus d. A is still the absolute value of a, and it's still your vertical stretch or compression. Hopefully, that's not anything you ever mess up again. The period is still one cycle, but what do I divide by the absolute value of b? Pi, because it's a cotangent. Okay, so that's the biggest issue there, is that it's not 2 pi. That's for the sine and cosine in their reciprocals. Tangent and its reciprocal are pi. Frequency is still the absolute value of b. To find it if I need to, it is pi divided by the period. Phase shift is still c. Vertical shift is still d. Midline is still y equals d. Okay. And that's going on page 95, so if you want to write that where there's a little place to do that, be good. And then we're going to grab our other piece of paper. All right. And this is going on page 96 when we're done. And we are graphing the reciprocal functions. This says all reciprocal functions have vertical asymptotes, all 3 of them. We just figured that out, right? And then it also says reciprocal functions do not have an amplitude. So the only thing with an amplitude is sine and cosine. That's it. Those 3 graphs are there for us to sketch our parent function, but we just did on bigger, better graphs, so I just have never taken those off. We're just going to skip them. You can sketch them in later if you want. So talking about the parent functions, the period of cosecant and secant is 2 pi, right? And the period of cotangent is what? Pi. Okay. Everybody good so far? Okie dokie. So let's do a few of these. Number 1, what is A? 3 halves. All right, your A is your 3 halves. What's frequency? 1. So the period is 2 pi. Do I have a phase shift? No. So it's 0. Midline is at y equals 0. All right, this is cosecant. Cosecant is the reciprocal of what? Sine. So I'm going to have a little sine parent function to follow over here. And I'm going to sketch in my midline. Okay. All right, so where I start here, when sine is 0, cosecant is going to have an asymptote because it's undefined. And so I would start on the axis. The only thing that would affect that asymptote being on that axis is if I had a phase shift, and I don't. So I have my first asymptote right here, right here. Oh my goodness. Go away, right here. Okay. All right, so then, just like the rest, we're going to do beginning, end, half, half, half. So at the end of the period, I also have an asymptote. The period is 2 pi, and I don't have a phase shift, so I have another asymptote at 2 pi. Halfway between, I have a third asymptote, and it goes here at pi. So for sine, halfway between these first two zeros, I would go up whatever the amplitude is. So I don't have an amplitude here, but it's still my A value. There is no reflection, so from the midline, I'm going to go up pi 1.5. So halfway between these two, I go up 1.5. And then halfway between these two, I go down 1.5. That make sense? See how to follow this? Instead of making a new one that will be weird and confusing, just use the sine graph and think about the reciprocals. Now that you've got that, we can just repeat it. So here I still have an asymptote at every pi. And then I have points here. And then you can sketch this in. Okay. What questions do you have? We good? Okay. All right, so then let's look at number 3. What is A in number 3? 1, right? A is 1. What is the frequency? 4/3. So then what is the period? 3 pi halves. Good. Do I have a phase shift? No. And then midline is at y equals 0. Secant is the reciprocal of what? Cosine. So I would sketch myself a little cosine parent function there and sketch in my midline. Then I'm also going to circle this negative sign here because I wrote everything else down over there, but I didn't write that down because it wasn't asked of me, but I got to make sure I pay attention to it, right? Okay, so I start on the axis up whatever A is. The only thing that affects it being on the axis is a phase shift, which I don't have. But instead of going up from the midline, that's a reflection, so I'm going to go down from the midline, 1, and my first point is there. The end of the period has the same y value. The period ends at 3 pi halves, and I do not have a phase shift, so I have a point right there. Halfway between those two, I'm on the other side of the midline, whatever A is. So halfway between those two, I'm here. Then halfway between those first two things we graphed. Oh, I just realized what I did. I think I moved. My goodness. Okay, whatever. Move my whole little bracket. At 0, I'm really going to have asymptotes. Right, so halfway between those, I can draw in asymptotes. Then I've got all my anchor pieces done. Then I should be able to repeat. Okay. Any questions about where anything came from? All right. See how the process is trying to keep it very consistent so we don't have a bunch of new weird things to do. We'll just do the same kinds of things and we can get what we need. What questions do you have? Anything? Okay. Good. All right, let's go on to the next one. All right. What is A here in this one? 3. What's the frequency? 1/2, which makes the period what? 2 pi. Good, because the period for cotangent is pi, and I divide by 1/2, I get 2 pi. I do not have a phase shift. Midline is at y equals 0. Cotangent is the reciprocal of tangent, so I'm going to sketch in this weird looking parent function right here off to the side so I have something to work with. And my midline is at y equals 0. Okay. So when tangent is 0, what is cotangent? Undefined. So I'm going to have an asymptote to start with. The only thing that makes it not start on the axis is if there's a phase shift, and there isn't one. So it starts right here. Then at the end of the period, I'm going to have another asymptote. End of the period is at 2 pi. So there's one right there. Halfway between the two, tangent is undefined. So what does that mean for cotangent? 0. So halfway between those two at pi, I have a 0. Halfway between the asymptote and the 0, I would go up, and there's no reflection, so I am going up from the midline, whatever A is. So halfway between these two, I'm going to go up 3. And then halfway between the last two pieces, I would go down 3. So my graph then looks like this. Then I can repeat that and get the rest of it in there. What questions you got? We all good on all that? All righty. Then let's look at number 7. What is A in number 7? 1. Frequency is 1, so the period is 2 pi. Phase shift, I do what? Right, okay, sorry, I'm going to go the right pi fourths. Midline is at y equals -2. All right. Cosecant is the reciprocal of what? Sine. So I'm going to sketch in myself a little sine and then sketch in my midline. All right. Sine starts with a 0, which means cosecant starts with an asymptote. The only thing that affects it being on the axis is a phase shift, and I do have one. So I go to 0, but I move to the right pi fourths. That's where the beginning of that period is, right? The end of sine is a 0, which means the end of cosecant, the first period, is an asymptote. The period is 2 pi, so I'm going to go to 2 pi, but I'm going to move to the right pi fourths. There's the beginning and the end. Halfway between the two is an asymptote. You got a couple of options. You can count and get halfway, or know that pi would have been halfway before we moved over, so I can go to pi and then move over pi fourths. Whatever works for you is fine. Halfway between the first two asymptotes, I would go up from the midline, whatever A is. There is no reflection, so I am going to go up from the midline. A is 1. Make sure you're doing this from the midline, and then halfway between the last two, you're going to go down one from the midline. And that's what the pieces look like. Everybody okay with that? Can you finish it off then? All right. And that's what it should look like. Okay. What questions you got? All right, so we're going to stop here for today. Your assignment for today is in Delta Math. It's not graphing. It is the reciprocal values for your trig functions, which I think some of us need to brush up on. If you've got them down pat, it should take you like 5 minutes. You'll be done. But I want you to practice with those, and then tomorrow we will do some more graphing by hand. Okay? We all good?